Okay, so in this question we're talking about a spring mass system that's oscillating with an amplitude of 0.15 meters. Let's talk about the KE first. We were told that the maximum speed is 1.2 meter per second. So the maximum KE can be calculated quite easily. Let's put in all the numbers. So this turns out to be 1.8 joules. The maximum KE of course occurs when the oscillation is at the equilibrium position. So we have 1.8 joules of KE when it's at the equilibrium position. At the extreme positions, the oscillation is of course at rest. So it will be a 0 here and a 0 here. Next, we'll talk about the changes in the GPE. Since the amplitude is 0.15 meters, so in going from the equilibrium position to the extreme position is going to involve a change in vertical height of 0.15 meters. So the change in GPE is going to be calculated, and we get the number 3.7 joules. So taking the GPE to be 0 at the equilibrium position, when it is at the top, the GPE will be higher by 3.7 joules, whereas when it's at the bottom position, the GPE is lower by 3.7 joules. Now the most interesting part of this question is of course the elastic potential energy. It's quite possible for you to solve for the spring constant of the spring mass system, and from there you can actually calculate exactly what's the changes in the EPE. But I don't think that's the intention of the setter. What the setter had in mind is something much simpler. You just have to be alert to the fact that the elastic potential energy does not increase linearly. Instead, it increases quadratically. In fact, the formula is of course half kx squared. So let's suppose that this is the equilibrium position, and when it's at the top, of course it's extended by a smaller amount. When it's at the bottom, it's extended by a larger amount. So the distance from here to here is 0.15 meters. From here to here is also 0.15 meters. So what you have to notice is that the increase in EPE going from here to here, which is this amount here, is smaller than the increase in EPE going from here to here. Alright, so let's call this the change in EPE 1 and 2. So basically we are looking for numbers that show that the difference between these two numbers has got to be smaller than the difference between these two numbers. This is simply because of the nature of the elastic potential energy. It increases in a quadratic manner. So for example, in option A and B, we see that we have an increase of 1.9 joules going from the top to the equilibrium position. So we expect the increase in the EPE from the equilibrium position to the bottom to be larger than 1.9 joules, simply because of the quadratic nature. Alright, so option B, which shows an increase of of just 1.9 going from here to here, cannot be right. Whereas option A, which shows an increase that is larger, would make sense. So based on, I think to arrive at option A, we just need to make sure that the KE is indeed 1.8, and you got to search for an option that shows the increase in EPE to be larger going from here to here compared to here from here. Okay.